Welcome back to the deep dive. Today, we're really getting into something fundamental. It's about ensuring quality, making sure the stuff we produce in projects actually hits the mark.
Yeah, and the material we've got here, it looks like it's maybe from some project management training. It's focused on quality, specifically like a key task within that whole PMP process domain thing. Gives a real structure.
Right, a structure for thinking about quality, not just as like a final check at the end, but something you build in all along.
Exactly.
So our mission, let's say, for this deep dive is to kind of break down these core ideas about managing quality that are in these sources, look at the processes, the tools they talk about, and how it all fits together so you can get a better handle on it for your own work.
And it's positioned really centrally here. Quality isn't some side activity. It's core to the process of managing a project. If you look at frameworks like the PMP's exam content outline, the process domain is, well, it's huge. It makes up half the exam, actually.
Yeah, 50%. That's where all the how-tos of project management lives, right? The tasks, the steps you actually do. And managing quality is a massive piece of that how.
hmm And this doesn't matter if your project is super planned out, predictive, or more flexible and agile, or somewhere in between.
These principles apply across the board.
Absolutely. Ensuring your output meets expectations, that's always key. And this material breaks it down into basically three main processes that work together.
Okay, three core processes. Sounds like they probably map to the typical project phases. Planning, doing, checking.
Pretty much, yeah. You start with plan quality management. That's obviously in the planning phase.
Makes sense.
Then you move into manage quality.
Yeah.
That happens during the executing phase while you're doing the work.
Okay.
And finally, there's control quality. That fits into monitoring and controlling.
Okay.
So yeah, plan it, do it while managing for quality, and then control it by checking.
So it's a flow. Define what good looks like, actively build it in, and then verify you got there, not just waiting till the end and hoping.
Precisely. So let's start with that first one, plan quality management. At its core, this is where you figure out, okay, what are the quality requirements for this project? What standards do we need to hit for the deliverables? And crucially, how are we going to prove we met them?
Right, documenting the how and the main benefit of doing this planning up front.
It gives you that roadmap, like you said, clear guidance, direction on how quality is going to be managed, how it's going to be verified, right from the beginning through to the end.
And the tangible thing you get out of this process is the quality management plan, right? What goes into that?
Yeah, that's the key output. The quality management plan is your playbook. It details things like the specific quality standards you're aiming for, measurable objectives like how good is good.
Okay.
It outlines roles and responsibilities, who owns what part of quality, how you'll actually meet the requirements, how the whole quality effort will be managed day to day, and really importantly, procedures for when things go wrong.
Like what to do if a part fails inspection.
Exactly. Procedures for nonconformance, how you'll handle corrective actions to fix problems, and even how you'll learn from it for continuous improvement. It's meant to be comprehensive.
But planning all this, doesn't that add time and cost? How do you know if it's worth it?
Good question. And the material brings up cost-benefit analysis for exactly that reason.
Yeah.
You literally compare the cost of putting these quality steps in place against the benefits you expect to get back.
So is this extra testing step worth the cost compared to the potential cost of releasing a bug?
Precisely. And the benefits they list are pretty compelling. Less rework, which is huge.
Saves time and frustration.
Totally. Higher productivity because you're not constantly firefighting. Lower overall costs in the long run. Happier stakeholders or customers.
Yeah.
And if it's a business thing, potentially higher profits. It's an investment, really.
Investing to avoid bigger pain later, that makes a lot of sense. And related to cost, the material breaks down quality cost itself, which is, well, it's quite revealing.
Yeah, this is a really important concept. They split it into two main buckets. First is the cost of conformance. This is the money you spend proactively during the project to avoid failures.
Okay, the good costs, kind of.
You can think of it that way. It includes prevention costs, things like training your team, documenting processes properly, getting the right equipment, just giving people time to do it right the first time.
Right.
And appraisal costs, the cost of checking, like testing, inspections, maybe even destructive testing where you have to use up a sample.
Okay, so that's the cost of building quality in. What about the other side?
That's the cost of nonconformance. This is the money spent because things went wrong. And they stress this happens during the project and after.
Ouch.
Yeah. It includes internal failure costs, mistakes you catch yourselves, like having to do rework or scrapping materials, things that cost you time and money but haven't hit the customer yet.
Okay, bad, but maybe contained.
And then there are the external failure costs. These are the really damaging ones. Failures found by the customer. Think liabilities, warranty work, dealing with complaints, and potentially the biggest cost, lost business, damaged reputation.
Wow. Yeah. When you put the cost of a bit more training against the cost of a product recall or losing customers, it really highlights the value of that conformance spending.
It completely reframes the discussion, doesn't it? So, okay, you've done your planning. Now you execute. That brings us to manage quality.
Right. This is happening during the execution phase, taking the plan and making it happen, embedding it in the actual work.
Exactly. And the main focus here, the key word, is defect prevention. It's explicitly called out as a proactive process. You're actively looking at your processes to make sure they're capable of producing a quality result, trying to stop errors before they occur.
So the benefits are things like, well, actually meeting your quality goals more often.
Definitely. Increases the probability of hitting objectives. It also helps you identify processes that aren't working well or figure out the root causes of poor quality while you can still fix the process. And it uses data from the control step we'll talk about next to keep everyone informed about how quality is looking.
And they give an example activity here, quality audits. What's involved in those?
Think of it like a process health check. It's a structured, often independent review to see if the project activities are actually following the rules, the policies, processes, procedures you laid out in your plan.
Can be scheduled or just random checks.
Both. And it might be done by someone internal who's trained or sometimes an external third party. A key part is often reviewing the quality management plan itself. Is it still relevant? Are people using it? Can we improve it?
So it's not just about catching bad products, but improving the way you make them.
That's the main point. It's about process improvement. The findings from audits are super valuable, not just to fix things on the current project, but also for lessons learned, helping future projects or other parts of the company. The objectives are things like confirming good practices, finding flaws, helping the team improve, documenting lessons, sharing best practices. It's all about getting better at how you work.
Okay, so plan quality management sets the stage. Manage quality focuses on proactively ensuring good processes during execution. Now the third one, control quality. Monitoring and controlling phase.
Right. Control quality is where you're actively monitoring the results of your quality activities and recording them to assess performance against the standards.
And the focus here shifts, doesn't it? Manage was prevention.
Exactly. Control quality is primarily about defect identification. It's more reactive. You're inspecting the output, the deliverables as they're being produced, looking for errors, finding defects so they can be corrected.
So this is about making sure the actual thing you're building is complete, correct, and meets what the customer asked for.
Yes. The key benefit is verifying that the deliverables meet the specified requirements, making them ready for stakeholder acceptance.
So that distinction is key. Manage quality, process focus, prevention. Control quality, product focus, identification.
You got it.
Yeah.
And they reinforce this. A quality audit is an example of managed quality. An inspection is a classic example of control quality.
Right. And I remember a diagram showing that flow. A deliverable comes out of the work, goes through control quality, maybe your internal QC check, and becomes a verified deliverable. Then that verified thing goes to the customer or sponsor for validate scope, where they check it. If they accept it, then it becomes an accepted deliverable.
Exactly. Control quality is your internal check against the specs. Validate scope is the customer's check for acceptance. Two crucial steps.
Okay, now to actually do all this planning, managing, controlling, the material lays out some really practical tools and techniques. Let's unpack some of those.
Definitely. A big part of quality is figuring out why things go wrong. So root cause analysis tools are key. They mention cause and effect diagrams.
The fishbone diagram.
Wow.
Or Ishikawa, I've seen those. They help you brainstorm potential causes, right?
Precisely. Fishbone, why, which relates to this tool. Ishikawa, same thing. They help you visually organize potential causes of a problem into categories. You often see categories like the 6M's: manpower, methods, machines, materials, measurement, Mother Nature, or environment. Help structure your thinking to find that root cause.
And then there's the simpler 5 whys technique.
Yeah, simple, but surprisingly effective. You just keep asking why. Starting from the problem. Why did this happen? Okay, why did that happen? You drill down. The material notes you don't have to ask exactly 5 times, but you keep going until you hit the fundamental reason.
Like peeling an onion.
Kind of, yeah. So those help find the why. What about tracking performance over time? Is our process stable?
For that, they talk about control charts.
Right. These charts track process data points over time to say the diameter of a part coming off a machine and compare them to statistically calculated limits.
The UCL and LCL, upper and lower control limits.
Exactly. Think of them as guardrails. If your process is humming along nicely, the points will bounce around randomly between those limits. But if a point goes outside the UCL or LCL,
Alarm bells.
pretty much, it signals that the process isn't stable, something special happened, it's out of control, and you need to investigate and fix it. It gives you a visual warning system for process health.
Okay, so control charts track the process. What about checking the actual output, the product itself?
That's where inspection comes in, simply examining the product or deliverable to see if it meets the documented standards. Or, if you fixed a defect, inspecting to make sure the repair worked.
Can be done at any level, component, final product.
Any level. The goal is verification against the spec, and the outcome is, hopefully, verified deliverables. But inspecting every single item might be overkill or impossible sometimes.
Right, like if testing destroys the item.
Exactly. Or just too costly. So they mentioned statistical sampling.
Checking a representative part instead of the whole population.
Yes. You choose a sample, maybe randomly, maybe systematically, like every 10th item, and inspect that. Based on the sample results, you make an inference about the quality of the whole batch.
Like tasting one cookie to see if the batch is good.
Perfect analogy. You just need to be careful about your sample size, how often you sample, the cost, making sure it's representative.
Okay. And one more tool. For when you have multiple problems, how do you decide which one to tackle first?
That's Pareto analysis, using the Pareto principle, the 80-20 rule.
The idea that like 80% of your problems usually come from only 20% of the causes?
That's the one. Pareto analysis helps you prioritize. You usually plot the causes of problems on a bar chart, order from highest frequency or impact down to lowest. Then you add a line showing the cumulative percentage.
And it usually shows that the first few bars account for most of the problems.
Often, yes. The example given was in manufacturing, where maybe raw materials cause 60% of defects, manufacturing errors cause 30%. That's 90% of your problems right there from just two areas.
So the chart tells you, focus your efforts on fixing those two things first for the biggest impact. Don't get bogged down by the minor stuff initially.
Exactly. It guides your improvement efforts efficiently. Now, these tools are useful everywhere, but how quality is approached overall can differ. The material contrasts traditional versus agile.
Okay, so in a traditional project, maybe like waterfall, how's quality handled there?
Typically, the planning is very detailed up front. Quality standards and processes are defined early. Then, the control quality checks, often by the PM or a QC team, happen at major milestones or towards the end, verifying against those initial fixed requirements. Changes usually need a formal request.
More structured, more gate-based, and agile.
Much more fluid and continuous. Quality isn't just one person's job. It's a shared responsibility team, customer, product owner. Quality is built and checked within each iteration. Think continuous testing, frequent feedback loops, retrospectives to improve the process cyclically.
So testing and improvement are integrated into the short work cycles.
Yes. And there's flexibility. Quality metrics might evolve based on customer feedback and changing needs. The focus is on delivering value incrementally and adapting, rather than just hitting a fixed spec at the very end.
Right. Traditional, define, build, check big chunks. Agile, define a bit, build a bit, check a bit, learn, repeat.
That's a good summary of the difference presented here.
Okay, so we've covered planning, managing, controlling the tools, bringing it all back home. Why does this matter to you listening? Whether you're running huge projects or just trying to make your own work better.
Well, fundamentally, understanding this stuff gives you a way to be more deliberate about results. You move from just hoping things work out to actively designing quality and checking that it's there.
Which means?
It means less rework, which saves you time, money, hassle. It avoids those costly non-conformance issues we talked about. It makes your work more efficient, more predictable, and ultimately, you get better outcomes, which means happier stakeholders, happier customers, maybe just happier you.
And those tools aren't just for big projects, are they?
Not at all. Like you said, using 5 whys to figure out why you keep forgetting your keys, or a simple Pareto chart to see which couple of tasks are eating up most of your time. These are powerful problem-solving techniques you can use anywhere.
So it's practical knowledge for improving how you work, period.
Exactly. It's not just abstract project management theory. It's about getting better results.
It definitely shifts the perspective, thinking about quality as something you actively build and manage, not just inspect at the end.
It really does. Which kind of leads to a final thought, maybe something for you to ponder. We talk about the cost of conformance spending money up front to prevent problems versus the cost of non-conformance spending, often more money, later because of failures.
Right, the prevention versus correction cost.
Yeah. So thinking about that difference, how might consciously deciding to shift more of your effort, your focus, maybe even your resources towards prevention, towards that managed quality idea of building it in, right? How might that fundamentally change how your next piece of work turns out, whether it's a project, a task, whatever? What would change if you focus more on preventing the fire instead of just putting it out?